Let's graph a log. Every time when you did your homework last night, and when we did the lesson yesterday, every time you had a log that you had to find the inverse of, what kind of function did you get back out? Exponential, absolutely right. Exponential growth or decay. And every time you had an exponential, meaning the variable was in the exponent, you should have gotten a log back out. Yeah. What? Yeah. See it blinking? All right. So if you think about whenever we initially talked about inverses, and we talked about if this was the graph of a quadratic, then the graph of the inverse would look like that, right? Because it switches the x and the y. Y'all following me? So think about this for just a minute.
Like domain.
Right. Logs and exponentials are inverses of each other. Scroll up. Whew, excuse. So think about this for just a minute. We did growth and decay. So let's just look at a growth. A growth looks like this, and it has a horizontal asymptote, right? So this is an exponential function. Based on what you know about exponential functions and logarithmic functions, what do you think is going to change when I graph the logarithmic function? The asymptote is going to change. It's going to be vertical now. And this time, let's see, if we flip this one, it's going to look like this. This is what a logarithmic graph looks like. Graphed. Now, let's talk about, oh, excuse me, the equation. A little familiar? Yeah. A little bit? Here's the difference. This number is going to be, before the number on the end was your asymptote, right? Now the number on the inside is your asymptote, and instead of it being horizontal, it's my vertical asymptote. And from there, there's no easy point on this one to plot. So from there, I'm just going to pick, and this is the hardest part about it, I'm going to pick 2 points to plug in. And I'll show you why this can be kind of tricky sometimes. You want to pick 2 points that are easy to calculate. So think about some of the properties you know. If the base is the same here, what does that equal?
That's just going to be
the exponent. What's the exponent on it though? 1. It just equals 1. Okay. Whatever that exponent is on it, that's what it's going to equal. So you want to think about things like that when we're plugging back in to see what works.
Because then you just plot that.
Correct. If H or K are missing, what are they? 0, because I'm adding. So I'll give you a second to copy that, and then we'll actually graph one and do the domain and range on it. Right. Let's do This one.
Three asymptote.
First thing I want to do is graph the asymptote. Where is the asymptote here? -3.
Why -3?
Anything inside parentheses like that, because the original one was -h, so you might want to put your note here that is opposite sign. Well, it's in parentheses here, but because of this minus sign here,
So if it's negative, then
make
it's
it positive. Correct, correct. All right, so y equals -3. Oh, x equals, I apologize. Was this vertical? One, two, three. All right, so now's the part where I need 2 points and I need to pick these 2 points, okay? So what you've really got to think about, and I'm gonna call them easy points, is I want some things that whenever I plug in here, it's gonna make my life really easy as far as calculating what the value is, okay? So I know, that if these numbers equal the same thing that this does, that's an easy calculation, right? What can I plug in for x to make these numbers equal to? -1. That's a good one to plug in. So when I plug that in, I get log base 2. Because I'm trying to make these parentheses be the same thing as this little base. Just so it's easy for me to calculate. So I get nice whole numbers. Log base 2 of 2 is what? What's log base 2 of 2? 1, and 1 plus 1 is... So this easy point is -1, 2. There's one other way to manipulate it so that it's easy. Log base 2 of 2 is 1. And then you have that plus 1 off to the side.
Cancel out?
What cancels out?
2 and 2.
Yes, and it leaves the exponent that's on the 2, which is a 1.
So then you add the exponent and then write the number?
Right. What is log base b of 0? 1. No. Let me change that around. What is that? 0. Because anything to the 0 power is 1, right?
Where did you keep?
So if I can now force this to be equal to 1,
Where did you get log b 1 0?
I'm just saying, this is a property if you think about it. I mean, it's not a given property, but if you think, doesn't matter what this base is, if it's got to equal 1, the only exponent you can raise it to get 1 is 0. Because anything to the 0 power is 1.
Then how are you going to put that back in there?
So how am I going to do that? How am I going to force what's circled in green to equal to 1? -2.
So you plug in the x and -3, -1 plus 3.
-2 plus 3. I need what's in parentheses to equal 1. So 0 plus 1, which is 1. And now you can tell which way it's going to go to hug the asymptote.
So your log b would have to have f1.
Right, right, to make it equal 0. What's the domain on this function?
How would you get negative 2?
Where did you get negative 2?
The very beginning. 3.
How do you force that to be 1?
Let me put that in there.
Range? Yeah. What did I do? Ah, I sure did. I apologize.
What happened?
I plotted 0, 1 instead of negative 2, 1. Ah, stop, undoing, stop, undoing. Negative, there we go. Thank you, Catherine.
So negative 2, negative 1.
Correct.
Negative 2, 1.
So we said negative 3 to infinity and negative infinity to infinity. So easy points, force the bases to be the same or force your, what's hooked to the logs, your A, to be 1. Does that make sense? Y'all are saying yeah, but I highly doubt it right now.
No, it doesn't.
Let's do another one. Negative infinity to infinity.
Wait.
Why is it what? Because any time, any log that you have, and I'm going to come back to this one. Yeah, I am. Anytime you have this, it doesn't matter what this number is, it equals 0. So here, log base 2 of 1 is 0.
Okay, 0 plus 1. I think that's supposed to be equals 1. But it looks
It is.
So log B 1, but how is it log 2 and not log B?
The original equation. Back up to the original
So
equation.
log 2.
Yes, Ozzy.
Wouldn't like it be like a straight thing, like the domain would be, and that one thing, the negative thing.
The reason it's not a bracket and it's a parenthesis is because it asymptotes, they can never actually touch. So brackets mean that it includes the number, parentheses means it does not include the number. Let's look at one more. Shamik, don't nobody know what you're talking about.
Yeah, she do it. That makes you look equal.
What's the asymptote?
Positive 2.
Positive 2. All right, I need 2 easy points.
Give me 1 second, please.
Okay, tell me when you're ready. Before we start. When you do your easy points,
Yeah, easy points aren't getting me.
okay, the first easy point you do, you know how you have log base B of A? And that A could include, that's really like your x minus h. Okay. First thing I need to do from one of the easy points is make the x minus h equal the base. Okay?
Just put 5 in for x on the equation that we just did.
Yes, absolutely. Okay? So whatever is in parentheses here, make it, force it to be the same thing as b, and that's the first x you choose. Okay? The second x you choose is you need to make x minus h equal 1.
How did you do that?
Okay, so let's look at how we do that. All right, so I need 2 easy points. The first easy point,
It'd be 5.
I'm going to make x minus 2 equal 3. So what do I need to plug in for x? 5. So now y equals log base 3, 5 minus 2, plus 4. Log 3 of 3 plus 4, We did this because log base 3 of 3 is 1.
So then 5.
So then this point is 5, 5.
I like that.
Okay? 1, 2, 3, 4, 5. 1, 2, 3, 5.
This one.
Yes.
You said for the first easy point, make x minus h equal to base. For the second easy point, what did you have?
Make the x minus h equal to 1.
So we use 3, so it's 1.
Yes. So I would need to plug in 3 for the x.
So wait, you're going on to another one, sorry.
It's okay.
X minus 2 equals 1. Because we know, wait, what? How did you get 1?
All right, so look, the second easy point,
Oh.
make x minus h equal 1.
Okay, fine.
Okay? So now I'm going to plug that in. Y equals log base 3 of 3 minus 2 plus 4. What is log base 3 of 1? 0. And 0 plus 4 is?
Why,
Anytime this number is 1, then it's 0. So now I've got 3, 4. 1, 2, 3, 1, 2, 3, 4. What is the domain? Somebody said it. What is it? 2. Positive infinity. And how about the range? Notice this is switched out from the exponential. Before, the domain was always negative infinity to infinity, and the range was what was restricted, and now it's vice versa. What you think? Easy? Too easy?
That's easier now.
Okay.